Hello, everyone. Good morning, afternoon, evening. Dear authors and invited guests, welcome to Technical Session 5C. Myself, Ashutosh Goyal, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastic, it is my great pleasure to welcome you all to the International Conference on Technological Intelligence and Business Strategies, TIBS 2026, Manila, Philippines. This conference is being organized in a hybrid mode. The physical event was held on 22nd June in Manila, Philippines, and the virtual event is being held through Zoom from 23rd to 24th June 2026. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 8 presentations. Each presenter will be given 12 minutes for the presentations and 3 minutes for question and answers. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chairs for this session. Professor Malinka Ivanova and Dr. Latika Desai. Professor Malinka Ivanova is an associate professor in the Department of Informatics at the Faculty of Applied Mathematics and Informatics, Technical University of Sofia, Bulgaria. Her research interests include e-learning, personal learning and adaptation, technology-enhanced learning, intelligent technologies for learning and teaching, Web 2.0, social networking, and security and privacy. She is the author of many papers published in conferences, proceedings, journals, and book chapters. Thank you so much for joining us today, ma'am. I request you to kindly say a few words of encouragement to our participants.
Okay, thank you so much for your invitation to be here right now in your great conference. I wish success to all participants and to learn new stuff and to address new challenges in the research areas that are they involved. Thank you again.
Thank you, ma'am. Now moving on to the next chair, Professor Dr. Latika Desai. She is presently working as Dean Universal Human Values at Dr. D.Y. Patil College of Engineering, Akudi, Pune, India. She has total 25 years of teaching experience. She has published 33 papers in various journals, and she also has 2 copyrights from the Government of India. Her area of interest include digital electronics, data security, embedded system, and IoT cloud. Thank you for joining us today, ma'am. I also request you to kindly say a few words of encouragement to the participants.
First of all the best for your presentation. And it's an opportunity you are presenting here. And all the best for your presentation. Thank you.
Thank you, ma'am. Now, without further ado, let's start with the presentations. First, I would like to call upon Ma'am Bhavya Balakrishnan to present her paper on the title A Comprehensive Survey on GAN-Driven Institution Detection and Security Enhancement in IoT Systems. Do we have you here with us, ma'am?
Hi, I'm here.
Okay, ma'am.
Yeah, give me a minute to share the slide.
Sure, ma'am.
Okay, so could you please let me know how to share the slide? Slide is ready here.
Ma'am, there must be an icon on the Zoom meeting tagged as share. You can click on that icon and it will present the option of sharing which window you want to present.
Yeah, yes. Yes.
If you're not able to
Hope
share it,
it's
then
visible.
just a second.
Yeah, I'm sharing it. Hope you can see it.
Not yet, ma'am, but
Is it
it's
visible
loading.
for you? It's loading. Yeah.
Yes, ma'am, it's visible right now.
Yeah. So shall I start?
Yes, ma'am.
Yeah, good morning everyone. I'm Bhavya Balakrishnan, a research scholar at Tijon Institute of Technology, Bangalore, India. So I have done a survey on GAN-driven intrusion detection and security enhancement in IoT systems. So let me begin with IoT. It's a network of physical objects embedded with sensors, softwares, and connectivity technology. So all kind of devices starting from our household appliances to industry machineries can get data, share data, and also they can do things without any human intervention. But these IoT are very vulnerable because of many reasons, like weak security mechanisms, limited resources, and outdated software. So we need an intelligent security system which can protect our system. So though we have many mechanisms in place, like traditional intrusion detection, it has many disadvantages. The main reason is they are dependent on predefined rules and signature. So it's very difficult for them when they are encountering with new kind of attacks, especially zero-day attack, because previously it is unknown. Another problem here is with the data set, unavailability of the data set. So since we don't have enough data set to train the model, so we'll not be able to build a model which can detect the attacks properly. Apart from all these things, no IoT environment, it continuously produces data. So we need a mechanism which can detect the attacks in real time. So here comes the role of generative adversarial network or GAN. It basically consists of two components, a generator and a discriminator. So generator is able, no, it will be able to create fake data which can fool the discriminator. And the job of the discriminator is to discriminate between the original data and the fake data. So both of them know they compete each other and they both get better at their work. So generator will be able to generate fake data more and discriminator will be able to properly detect the fake data. So the role of GAN in cybersecurity is that since we have a lack of training data, we can generate synthetic data with GAN. So we can do better anomaly detection and intrusion detection. Also, we can simulate newer kind of attacks, which will be helpful for zero-day attack simulation. So this is the architecture of a GAN. So as I told, it consists of two components, a generator and a discriminator. So generator creates a fake sample, discriminator discriminates between the real sample and the fake sample. So here I have listed out the different applications of GAN in IoT system. It helps in detecting unauthorized access. It helps to find out the unusual behavior and for the anomaly detection. It helps to generate synthetic data so that we can overcome the limited imbalance data set. Apart from these things, it can create realistic cyber attack scenarios to test system resilience. So here, I have listed out various studies on GAN and IoT, and here I have differentiated each study based on the applications, methodology used, data set, key contributions, and limitations. So the first one, Horn, it has used, he has used deep encoder for intrusion detection with NSL KDT dataset. So it could have the improved, it has the improved detection accuracy, but it is not fully optimized for IoT constraint. The second paper, which is written by Lin, he has used Vanilla GAN for data augmentation using UNSW NB15 dataset. It could handle class imbalance, but training instability is a problem here. The third paper by Farag, which is written in 2021, he has used GAN based IDS for anomaly detection with CI/CADS 2027 dataset. It was able to detect unknown and zero day attack.
Excuse me.
Yes,
Sorry
yes,
for
ma'am.
interrupting.
Yes, ma'am.
Slides are not changing, no?
It is, ma'am. I am moving the slides. Now I am in this literature survey table.
Yeah, now it's fine. Okay,
Yeah,
thank
yeah, yeah. I have actually changed. I think it was not. Was it visible, ma'am? These were the slides which I showed. This was the first slide. Then second one, this listed out the problems with the traditional IDS. This was the third slide where I have introduced GAN. And this is the architecture of the GAN. And here I have listed out different applications of
now it's fine.
yeah, okay. Yeah. So I have stopped with the third study where it has used, it has introduced an GAN-based IDS framework for anomaly detection. So the key contribution was for this, about this paper was it could detect unknown and zero-day attack, but it had a limitation which was the high computational overhead. And the fourth study, which was by Al Rawshed, which was in 2022, he has used conditional GAN for malware detection using IoT 23. The key contribution here is, it could generate realistic malware traffic, but the limitation is about the real-time implementation. And the last study, it has used adversarial GAN for attack simulation using custom IoT dataset. It could evaluate robustness of the IDS model, but it had a problem which is dataset dependency. So, considering many, research of GAN and IoT, these are the gaps which I could find. The first thing is, it has limited real-time implementation. So the practical deployment is quite difficult. And many of the GAN model, it has high computational cost, which is difficult in a resource-constrained IoT environment. And many models has a problem which is, called as black box problem, which is basically explainability of the attack, which is a proper attack they'll not be able to properly, explain. And then yeah, as we told, like when they encounter with a completely new attack, it's difficult to detect it. And finally, the data set imbalance problem is also not completely solved. So this is the proposed methodology, which I am, suggesting, where GAN based intrusion detection, where these are the different steps where IoT data is collected first, then it is pre-processed, then GAN will solve this class imbalance problem by creating synthetic data. So this augmented data set is used to train the model, and this train an IDS model where this IDS will be able to classify the normal and the malicious activities. And finally, the performance will be measured by using different matrices like accuracy, precision, recall, and all. So this is the methodology, and with this methodology, we expect to have these listed outcomes, which is better identification of malicious traffic, and misclassification of attacks can be reduced. Even unknown attack, the system will be able to detect, and we can have a balanced data set by generating synthetic data using GAN. And moreover, robust and reliable IDS for real-time IoT environment can also be improved. So with all these things, I would like to conclude my topic where IoT environment, it's highly vulnerable to cyber attacks. So we can propose a method which can integrate traditional ideas with GAN, so which can enhance detection accuracy, reduce false positive, improve zero-day attack, and it can provide a more reliable security framework for IoT networks. Thank you, ma'am.
Nice presentation.
Yeah, ma'am. Thank you.
You are checked your accuracy, detecting accuracy with any researcher, previous researchers?
No, ma'am. I'm done. I have done a survey. The implementation is, still in. I mean, I have to start with the implementation. I have done the survey. I have done the research on this.
Attack you
Hello, ma'am. I'm not. You're not
Okay.
audible. Hello.
Just one more question.
Yeah, ma'am.
What kind of attacks do you have intention to see what happens?
Yeah.
Can
So
they will be detected?
yeah, mainly we are focusing on cyber security attacks like intrusion detection or malware problems. That's what no, I am focusing on. So that's what I would like to detect and find out using. Yeah.
Okay, thank you.
Thank you, ma'am.
Thank you for your presentation, ma'am.
Thank you, ma'am. Thank you, sir.
Now moving on to the next presenter.
So can I exit or should?
Ma'am, ma'am, I request you to stay till end of
Okay.
the meeting.
Yeah. Thank you, sir.
Now moving on to the next presenter, I would like to call upon Ma'am Siti Dui Hastuti to present her paper on the title Democratizing Digital Archive Learning for SDG 4 Inclusive Education Using a Cost-Effective VBA Excel Framework. Do we have it here with us, ma'am? Since there's no response, we'll be moving forward with the next presenter. Next, I would like to call upon Sir Ryan Naufal Ananto to present his paper on the title From Acceptance to Continuance, Investigating Trust and Privacy Risk in Mandatory AI-Based Biometric Boarding Systems at Indonesian Railways. Do we have you here with us, sir?
Good morning, respected members of the chair, honorable evaluators, and fellow presentation participants. Thank you for welcoming us today. I am deeply honored to present our group's latest empirical research study entitled From Acceptance to Continuance, Investigating Trust and Privacy Risks in Mandatory AI-Based Biometric Boarding System at Indonesian Railways. This research was conducted by me, Ryan Noval Anandito, alongside my esteemed colleagues Muhammad Fedlo Paginting and Tria Septiori Putranto, representing the faculty at Bina Nusantara University in Jakarta, Indonesia. Over the next 12 minutes, I will get you through a profound socio-technical paradox Our study departs from traditional technology adoption literature by looking into a realm that remains significantly under-researched behavioral intention within a completely compulsory non-discretionary environment. Specifically, we investigate how consumer mechanics shift when citizens are forced to interface with advanced artificial intelligence systems during their daily commutes. In this comprehensive breakdown, I will outline the acute operational challenges at Gambir Railway Station, our structural model integrating the technology acceptance model and the expectation confirmation model, our rigorous PLSM statistical results, and the urgent policy frameworks necessary to align national infrastructure with Indonesia's evolving data protection legal mandates. Let us begin by reviewing the structural catalysts of this deployment. To understand the core motivation behind this research, we must first analyze the unique operational landscape of the Indonesian Railway. Stasiun Gambir, located in central Jakarta, serving as a critical transport artery, handles hundreds of thousands of active passengers every single day. Historically, the standard terminal checkpoint workflow relied heavily on manual verification. Station gate officers had to physically inspect printed boarding passes or mobile QR codes alongside national physical identity documents, such as KTP cards, before allowing passenger access to the inner platforms. During extreme peak transit windows such as morning rush hours, weekend holiday departures, or seasonal exodus periods, this labor-intensive checkpoint paradigm routinely triggered severe bottleneck congestions across the main terminal hall, beyond causing substantial passenger stress and scheduling inefficiencies. This manual process introduced unmitigated vulnerabilities regarding human clerical error and sophisticated identity fraud. To aggressively mitigate these infrastructure bottlenecks, PT Kereta Api Indonesia implemented an innovative socio-technical pivot in 2023 by deploying an automated biometric boarding system directly at the south gate of Gambir Station. This advanced system uses a multimodal AI architecture that captures live facial scans and instantly cross-checks biological features against the centralized National Civil Registry database. By reducing identity verification time from minutes down to more seconds, the system established a contactless, hyper-efficient passenger flow. However, this engineering success opened an entirely new physiological frontier. While the physical advantages of removing queues are immediately apparent, the underlying socio-technical mechanism introduced a sharp post-adoption tension. Unlike traditional software authentication credentials such as alphabetic passwords, security phrases, or numerical pins, facial biometrics are intrinsically immutable. They are permanent, biological features tied irreversibly to an individual's unique physical body. Once biological data is compromised, leaked, or mishandled, it cannot be reset, modified, or reissued. This absolute unrevocable nature raises the stakes of data collection exponentially. Furthermore, this deployment exists in a mandatory framework. Passengers wishing to utilize these high-speed rail lines have no practical alternative but to yield their sensitive physical data. This structural reality places this study directly under the regulatory gaze of Indonesia's landmark Personal Data Protection Law, known nationally as Undang-Undang Number 27 Year 2022. Under UU Number 27 Year 2022, strict provisions govern the processing of sensitive data, rendering institutional trust and risk perception central pillars of public infrastructure viability. Our quantitative research models passengers' continuous intention, the long-term internal motivation to, consist, to consistently interface with the technology post-adoption by examining how trust coexists with deep structural privacy anxieties. Construct an appropriate analytical lens for this unique environment. Our study synthesized a composite framework uniting two primary theoretical paradigms. The first is Fred Davis Seminal Technology Access Model, or TAM, formulated in 1989. Classic time has served as the baseline for predicting technology adoption by looking into two primary utility beliefs: perceived usefulness, which measures the user's belief that a system enhances performance, and perceived ease of use, which measures how effort-free the interaction feels. In classic voluntary context, this utility beliefs directly construct a positive attitude toward using, which subsequently drives behavioral intentions. However, because traditional time is heavily optimized for initial adoption, it falls short when evaluating sustained long-term technological usage over time. To capture post-adoption behavioral adjustment, we integrated Anol Bhattacharya's expectation confirmation model, or ECM. The ECM states that after users gain actual hands-on experience with the system, they cross-evaluate their real-world outcomes against their prior cognitive expectation. This confirmation dictates the level of overall satisfaction, which directly fuels their long-term continuous intention. To adapt this combined time ECM framework to the modern, high-stakes reality of artificial intelligence, we added institutional trust and perceived privacy risks as core socio-technical pillars. This study utilized a cross-sectional quantitative survey design optimized to measure specific perceptual construct at a fixed point in time. Data collection was meticulously carried out over a 4-week period utilizing structured digital questionnaires distributed via Google Forms, directly within the physical boarding gate zones at Gambir Station and across online rail commuter communities. To prevent speculative responses, we employed a strict purposive judgment sampling strategy. Only passengers who had successfully completed the automated biometric face recognition process at least once were permitted to participate. Out of 162 total responses captured, 12 were omitted due to incomplete entries or failure to fulfill the experiential qualification criteria, yielding an analytical sample of N150 valid cases. Reviewing our demographic distribution on slide 5, male passengers comprised 55.3% of the sample, while females made up 44.7%. The age distribution was remarkably balanced, demonstrating broad cross-generational usage. Young adults aged 17 to 25 represented 28.0%, followed by older adults aged 46 and above at 26.7%, and mid-career cohorts split evenly. Private sector professionals constituted exactly half of the sample at 50%. Crucially, 100% of our respondents reported active prior familiarity with facial recognition technology across everyday applications, and 55.3% were periodic commuters transiting Gambir 1 to 2 times, ensuring a highly literated, experienced consumer base. We present the descriptive statistical profiles for each of our 7 latent constructs. All metrics were captured on a standardized 5-point Likert scale, spanning from 1 representing strongly disagree to 5 representing strongly agree. Interestingly, the statistical mean scores across all variables cluster extremely tight within a moderate to high spectrum, specifically between 3.297 and 3.392, demonstrating a generally favorable response baseline across the entire passenger cohort. However, a fascinating socio-technical anomaly becomes evident when we look closer at the boundaries of this data. Institutional trust in PTKI recorded the highest overall statistical mean score at 3.392. This indicates that commuters possess a fundamentally solid baseline of confidence regarding KAI's competence and corporate integrity. Conversely, the passengers' explicit continuous intention to keep using this AI system recorded the lowest overall mean score at 3.297. This contrast reveals a highly compelling psychological gap. While commuters respect and trust PTKI as a state-owned enterprise, they do not inherently hold an eager, voluntary personal desire to be continuously scanned biometrically unless structurally prompt. This structural tension sets the stage for our path modeling. Before evaluating the structural model and interpreting our path directions, we perform a comprehensive measurement model validation. Following the strict guidelines established by Hare and colleagues, construct reliability was fully established across all metrics. Chromebox alpha values range from 0.827 to 0.849, while composite reliability parameters PA and PC span from 0.831 to 0.897. Comfortably, exceeding the academic benchmark of 0.70. To confirm robust internal consistency, convergent validity was also confirmed as the average variance extracted, or AVE, for all 7 constructs safely surpassed the mandatory 0.50 threshold, ranging from 0.649 to 0.686. Furthermore, discriminant validity was thoroughly validated via two separate tests. First, under the classic Fornell-Lacker criterion, the square root of the AVE on the diagonal for each construct successfully exceeded any correlation with other latent factors. Second, the hetero-trait monotrait ratio of correlation remains strictly beneath the conservative 0.85 academic threshold, with the highest ratio peaking at 0.605 between perceived privacy risk and continuous intention. Finally, all
So this is a
interference
gentle
inflation
reminder.
factors remain under.
So this is a gentle reminder that you have crossed the 10-minute mark. So kindly conclude the presentation in the next 2 minutes.
Okay. This is the key hypothesis. Utilizing PLS-SEM with a comprehensive 5,000 respondable bootstrapping process. What is really groundbreaking here is the total structural collapses of the traditional term framework within this mandatory context. This counterintuitive path, where an increasing in privacy risk perception directly increases user attention to continue using an AI system. Because escaping or avoiding the AI gate is practically unfeasible without abandoning their transit plans entirely, passengers experience a physiological phenomenon known as learned helplessness. This effect directly resolves the classic privacy paradox. Commuters engage in a forced pragmatic risk-benefit in trade-off. They consciously choose to continue interfacing with biometric gates to secure rapid touchless access even while simultaneously harboring deep, unresolved anxieties. Translating these complex theoretical insights into actionable real-world governance, we present this vital strategic recommendation for PTKI and transport authorities. In conclusion, our research provides a vital theoretical shift. It proves empirically that under mandatory socio-technical conditions, traditional utility metrics like ease of use lose their predictive power, and primacy is shifted entirely to effective construct and trust mechanics. AI biometric boarding system must never be managed merely as tool of technical optimization. They must be designed and governed as trust-centered socio-technical ecosystem where engineering, performance, absolute legal transparency, and consumer psychology safety operate in harmony. Thank you very much for your time, your consideration, and your valuable attention.
Thank you so much for your great presentation. I have question regarding the challenging issues, if any, regarding the trust in your system from the side of users, and also what are your future work? Yes, some challenging problems regarding the trust in your system.
I'm sorry, challenging programs in?
Yeah, some challenging problems.
Oh, so there are several challenging problems in the trust and privacy risk. Sometimes people just don't want to give their privacy or face because that is their privacy, even though they are have to when they want to go to another state in Indonesia, they have to, but sometimes they don't want. So that must be one of the challenge from the passenger.
Thank you. Thank you.
Thank you.
Thank you, ma'am. Thank you, sir. Do you have any other questions?
Any other question?
Since there are no more questions, we'll be moving forward with the next presenter. Thank you for your presentation, sir.
Yes. Thank you.
Now I'd like to call upon Ma'am Riddhi Sharma to present her paper on the title Leveraging Information Theoretic Measures for Feature Selection and High Dimensional Data Mining. Do we have you here with us, ma'am?
Yes, sir.
Okay, ma'am.
My screen is visible.
Yes, ma'am.
Thank you, sir.
So, good morning, respected session chair and dear participants. I am Riddhi Sharma, research scholar from Chitkara University, Baddi, Himachal Pradesh. Today, I am presenting my research paper titled Leveraging Information Theoretic Measure for Feature Selection in High Dimensional Data Mining. This work focuses on role of information theoretic measures such as entropy, mutual information, and divergence measures in feature selection for high dimensional data mining, because high dimensional data mining often contain redundant and irrelevant features which increase computation complexity and reduce model performance. These are the outline of my presentation, and this presentation is organized into following sections such as abstract, introduction, literature review, theoretical framework for data mining, methodology, result and discussion, conclusion, and future direction. And by the end of a presentation, there are some references. So in abstract, uh, this study explores the role of information theoretic measures in feature selection for high dimensional data sets. High dimensional data often contain redundant and irrelevant features which increase computational complexity and affect classification performance. To address these issues, the study utilized entropy, mutual information, and divergence measures to analyze feature relevancy and dependency pattern. The proposed approach is compared to traditional methods and is found to handle nonlinear relationships and noisy data more effectively. Although challenges such as computational cost and scalability still exist, and the analysis shows that information theoretic measures can perform feature selection and support better decision making in data mining. Next is introduction. Data mining aims to discover hidden patterns and valuable information from large and complex data sets. However, high dimensional data often contain redundant and irrelevant features which reduce high computational cost and reduce efficiency. For this, future selection become an important pre-processing step for improving performance and interpretability. And traditional statistical methods are limited because they are unable to effectively capture nonlinear relationships among variables. So information theoretic measures such as entropy and mutual information provide an effective way to analyze uncertainty and dependency, especially in noisy and high dimensional data. And most existing studies uses these measures uncertainty and a unified theoretical framework that compares entropy, mutual information, and divergence measures is still limited. This research attempt to address that gap and compare with the traditional approaches to evaluate robustness and interpretability. And the objectives of my studies are to show how information theoretic measures improve feature selection in complex and high dimensional data, and evaluate if entropy and mutual information jointly and improve interpretability and redundancy reduction, and compare the proposed framework with traditional approaches in terms of stability and relevancy detection. And the major contribution of my study are: unified theoretic framework is proposed for feature selection and related data mining tasks, and this study examined the combined role of entropy, mutual information, divergence measures in handling complex and high dimensional data, and compare it with conventionals and information theoretic approaches is presented to evaluate relevancy detection, interpretability, and robustness. This is the literature review that show the evolution of information theoretic measures in combined with data mining tasks. Traditional feature selection method work well for small data sets but has still limitation in high dimensional data. To overcome these limitations, researchers introduced mutual information based approaches that improve relevancy detection but increase computational cost. And later, entropy based optimization based methods further improved classification performance, and other information theoretic approaches such as total correlation, information bottleneck provide better interpretability of complex and high dimensional data. However, issues like scalability and lack of unified framework is still limited. Therefore, the literature review highlight the need for unified information theoretic framework, which form the motivation for the present study. Therefore, this study propose a unified theoretic framework for different data mining tasks. Yes. Next, the theoretical framework of data mining. This theoretical framework, we define it in structured manner. It is divided into two parts, that is fundamental information theoretic concept and unified information theoretic framework. In fundamental information theoretic work, information theory play essential roles and quantify uncertainty, divergence, and dependency. Here, Shannon entropy measure the uncertainty. Mutual information measure the shear information between two variables. Kullback-Leibler divergence measure the difference between two divergence. And Jensen-Shannon divergence is the symmetric version of Kullback and measure the stable result as compared to Kullback-Leibler divergence. And in unified information theoretic framework, it is divided into four parts: feature selection, clustering, classification, and anomaly detection. And in this section, we use the information theoretic measures and applies in different data mining tasks. So in feature selection, mutual information measure the relevancy and reduce redundancy. And clustering and entropy based measures measure the similar and clustering informations. And in classification uh, and information theoretic measures improve decision making. And for an anomaly detection, Kullback-Leibler divergence evaluate the unused patterns. Next is theoretical properties and guarantees entropy-based robustness in sparse and high-dimensional data. Non-parametric measures like entropy, mutual information perform well even without assuming specific data assumptions. And Kullback-Leibler divergence connect these information theoretic measures strongly and also mathematically analyzable. And these properties improve robustness and interpretability for high-dimensional data sets. And in entropy based robustness in sparse high dimensional data, sparse data have irregular density distribution and missing observations. So traditional based methods become unstable, and entropy weights quantify uncertainty and associated with each features. And low vectored features with high randomness do not dominate the learning process. So this framework improve clustering, classification, stability of feature selection in high dimensional data sets. Next is methodology. We do not apply these information theoretic measures directly. So we have these estimation techniques. Uh, uh, First is histogram based methods. It is easy to interpret and estimate entropy using probability distribution. Next is k nearest neighbor estimation. It is effective for continuous high dimensional data and estimate entropy using distance between neighboring samples. Next, kernel density estimation. Kernel density play major role in estimation of probability density and also estimate smooth density of complex distribution. Next is mine. Neural network based models to provide scalability and high accurate estimation of mutual information in high dimensional data. Next is proposed information theoretic framework for data mining task. Here are four major tasks such as feature selection. In feature selection, we apply approach maximum mutual information and that keep the important information while reducing redundancy. And in clustering, we apply minimum description length. And this identified the relevant features. And in classification, information bottleneck that preserve the important information. And in anomaly detection, point wise Kullback-Leibler divergence is used, that is useful to detect unusual patterns. And next is computational complexity analysis to evaluate scalability. Here entropy estimation, feature selection, and clustering to evaluate and enhance observations of scalability. As the number of features increases, number of sample increases, and high dimensional cost is also increases. So this work is designed to work efficiently in high dimensional data environment. Next is the resultant discussion. Uh, Observation from information theoretic analysis. Entropy based measure improve understanding and not depend upon linear assumptions. And it is more stable in presence of noisy data and improve interpretation by reducing uncertainty and select relevant features. And in comparative analysis, mutual information is capable in identifying linear as well as non-linear relationship in comparison to traditional methods. Entropy-based approaches in classification and Kullback-Leibler digestions is anomaly detection results in more accurate interpretation. And information theoretic techniques improve relevancy detection, analytical flexibility, and interpretation.
Ma'am, this is a gentle reminder that you have crossed the 10-minute mark. So will you please conclude the presentation in the next 2 minutes?
So, give me 2 minutes.
Sure, ma'am.
Next, comparative analysis of traditional and information theoretic method. In this comparison, feature selection, feature selection, information theoretic approaches uh, compare with the traditional methods to give better relevancy detection, and in clustering gives flexible cluster information, and in classification they gives improved decision making, and for anomaly detection they give better anomaly detection. But there are still some limitations that entropy and mutual information become complex in high dimensional data environment, mixed type data and continuous feature remaining challenges. And in practical application, they are used for fraud detection, text mining, and support large scale data analysis with optimization technique. And analysis is based upon standard benchmark high dimensional data environment and used in data mining and feature selection. And source of these data sets is from domain of biomedical analysis and recognition of pattern, and variation in dimensions and data distribution support the border evaluation. This is our conclusion. So unified information theoretic framework for feature selection, clustering, classification, and anomaly detection. And information theoretic measures help in identification of uncertainty and hidden patterns. In comparison of traditional methods, these measures can detect linear and nonlinear patterns. And limitations are high computation complexity and sensitive to noisy or mixed type data. In future direction, we develop efficient estimation methods for real world data environment and integration of information theoretic measures with deep learning. So these are some references that I used. And thank you for your attention.
Thank you so much. Nice presentation. Also, the topic that you discuss is very important about the dimension of data and how they could be processing and extract the main valuable features. We see your challenging issues, future work. I have question about the deep learning and neural network. How do you think that it will enhance your architecture of methodology to extract the best features of your high dimensional data set?
Yes, ma'am. In methodology section, this work is theoretical. In future, I would like to implement the framework on real data sets such as biomedical fraud and detection and intrusion detection. And I would like to combine information theoretic measures with deep learning techniques and develop more computational efficient methods on large scale data analysis.
Okay, it's your intention to use some deep learning algorithm, and maybe it's your future work to decide what will be the architecture of this deep learning algorithm.
Yes, ma'am.
Okay, thank you so much. Thank you.
Thank you,
Great work.
ma'am.
Thank you.
Thank you, ma'am.
On to the next presenter. Thank you for your presentation, ma'am.
Thank you, sir. Thank you.
Now I would like to call upon Ma'am Nishi Doshi to present a paper on the title Night Window Batching versus Carbon Aware Scheduling for Clinical AI GPU Workloads. Do we have you here with us, ma'am?
Yeah. Hi, everyone. I'm Nishi Doshi, and I'll be presenting the paper titled Window Batching versus Carbon Aware Scheduling for Clinical AI GPU Workloads. This presentation is a talk is about a very practical question for hospital AI operations, where hospitals run more GPU workloads. When they run this, should they invest in a complex carbon aware scheduling algorithm, or can a simple night window batching algorithm capture most of the benefit? I'll use the phrase the pulse and the grid because those are the two forces in tension here. The grid changes by the hour, but clinical urgency does not. The goal is not to prove a clinical outcome. The goal here is to compare queuing policies in a controlled simulation and ask what is operationally worth deploying. Mhm. So hospitals are under pressure to reduce scope 2 emissions and show progress on net zero targets. At the same time, AI jobs are tied to clinical workflows. Some are routine, some are urgent, some are critical. That makes the hospital setting different from how a normal batch queue works and in a cloud setting. A cloud operator can move work around to chase lower carbon electricity. A hospital scheduler has to protect, however, the patient facing deadlines first. So the research question here is simply not can we reduce the carbon? It actually is can we reduce carbon without making clinical priority, without breaking the clinical priority ordering? Moving on to the next slide. This is the governance problem behind the paper. The dashboard generally shows how much a carbon is saved using a scheduling algorithm. And once it's saved, it shows like it looks successful, but it does not report the missed deadlines. It can hide that cost of the saving of carbon hides that cost. The risk does not disappear. It moves on to clinical staff who now have late jobs and delayed AI outputs. Vendor green modes, sustainability targets, and service level expectations can all pull in different directions. The paper asks whether complex carbon aware scheduling is really worth the added operational risk and complexity. We talk about the setting here. The study is performed in a controlled environment where we synthetically run 2000 patient style jobs on 3 urgency tiers and arrival rates of 24, 36, and 48 jobs per hour. The environment is heterogeneous 8 GPU cluster model, and carbon intensity here varies over time. We run against 13 scheduling policies for the same simulator. The key rule is that every policy is judged on 2 dimensions at the same time. Average kilograms of CO2 emissions and deadline behavior, especially critical tier deadline misses, since this is all for clinical AI workloads. That paired metric is the backbone of this paper. Instead of memorizing all the 13 different scheduling algorithms, we divide them into 4 categories. The first is the baseline for FIFO, SJF, and urgency only. These are the carbon blind and priority first algorithms, the simplest ones. Second is a simple deferral represented by night window deferrer, which is a rule-based policy that shifts flexible routine work into the night. Third is the complex hybrid policies such as CUCA and Slack aware that blend urgency, deadlines, and carbon dynamically to determine the scheduling algorithm. Fourth are the only carbon aware stress tests, such as carbon gradient, carbon shift. Those are not meant for production. They are included just to show how unsafe these green presets can be. Yeah. So here we report the findings of all 3 algorithms. The carbon only category is intentionally omitted here. Those policies are stress tests and, as I said, not deployable. We start with the urgency only as the baseline. It protects priority, but ignores carbon. So it has the worst carbon footprint, which is of 52.03 kgs of CO2 emissions. Next up, we can talk about CuCa 0.45, which is the complex hybrid. It gives the lowest carbon footprint, which is 44.71 kgs, but it requires tuning and it has higher critical miss rate than night window. Night window is in the practical middle of these two with 46.35 kgs of CO2 emissions and a critical miss rate of 0.08%. It also has like low implementation effort that makes it operationally sweet spot between the simulation. This is the core result. On the GATE study average, urgency only produces 52.03 kgs of CO2 as shown in the last slide. CuCa 0.45 brings that down to 44.71. On night window deferrer lands at the middle, which is 46.35. That means that the simple night window rule captures about 78% of the carbon gap between urgency only and CuCa 0.45. More importantly, night window has fewer critical deadline misses, 0.08% compared to 0.19% of CuCa 0.45, which is approximately 2.5x increase. In plain terms, the simple rule gets the most of the carbon value while being safer on the critical Q matrix. This slide explains why the simple rule performs well. Night window batching is not just a carbon trick, it's also changes Q shape. Flexible job routines are moved into lower carbon night true, and that has two effects. First, those routine jobs run at a cleaner time. Secondly, daytime GPU capacity is less crowded. This helps protect all the critical and urgent jobs that come during the day unpredictably in a hospital environment. So the rule works because it combines carbon timing with a Q buffer. It is simple enough to implement, but it still respects the clear clinical priority stack. This plot is the conceptual summary. We want policies towards the lower left, low carbon and low critical miss rate. Night window and CuCa sit near that useful frontier. Urgency only is safer than bad carbon first policies, but waste carbon opportunity. Carbon only rules move into hazardous zone. They may reduce average carbon, but they abandon deadline safety. This is why the paper argues that carbon cannot be optimized alone in the clinical AI infrastructure. At a very high utilization, where we run the jobs when we run almost 48 jobs per hour, night window averages at 47.65 kgs of CO2 emissions, while CuCa 0.45 averages at 47.69 kgs. That is essentially a tie, but the critical miss rates are not tied. Night window has 0.093% increase. Night window has 0.093% and CuCa 0.45 has 0.262% of critical deadline misses. The interpretation is straightforward. When the cluster is saturated, complex scheduling loses much of its carbon advantage, but the simple night window rule still preserves the useful Q protection. This is the warning slide. Essentially, carbon greedy and carbon shift are included as stress tests here. They show what can happen when carbon is made the first objective without hard critical clinical safeguards. Carbon shift reaches low carbon, but about 46% of the critical jobs miss their deadline in the GATE average, and critical P95 turnaround rises to about 165.7 minutes. That is not a sustainability win, it is a failed acceptance test. The practical rule is that any vendor green mode must be tested side by side against clinical priority mode before deployment. Sorry. Yeah, we're here. So CuCa, like talking more about the CuCa algorithm, it's not a magic button. It's like a tuning dial. As alpha moves more toward like 0.4, like below the 0.25, the policy becomes more aggressive about carbon. Average carbon falls, but critical misses begin to rise. that may be acceptable in certain environments and unacceptable in others. The point is that complex scheduling creates an operational tuning responsibility. If a hospital cannot continuously validate and govern this dial, then the simpler night window rule may be the safer default. We also run some simulations for two extensions. First is this geographic routing. In the geo battery, regions share the same daily carbon shape shifted by time zone. So the extra modeled carbon gain is very small, under 1%, about 0.2% in the comparison shown. That is before accounting for migration, energy, data locality, privacy, and latency. Secondly, when you move towards the long shift extension, extending routine deferral to 12 hours time only about, is helping to save only about like 0.8% carbon, but overall simulator deadline misses rise from 3.75% to 5.08%. The takeaway is that these are not harmless IT tweaks, they are clinical change control decisions. Hence, as part of this paper, we propose an operator playbook. Firstly, start simple. Document a strict
Ma'am,
night window.
this is a gentle reminder that you have crossed the 10-minute mark. So, you may please conclude the presentation for the next 2 minutes.
Sure. Firstly, we start simple. Document a strict night window policy with explicit deadline buffers before buying heavy orchestration. Secondly, we mandate side-by-side tests. Vendor green modes should be compared against clinical priority modes during acceptance testing. Third, pair the matrix, never report kg of CO2 emissions without the missed deadline counter next to it. Fourth, control the changes. Longer deferral windows should require clinical sign off because they change tardiness risk. These are operational safeguards that keep sustainability from undermining clinical service levels. Yeah, so we conclude here, and the conclusion as we present is conservative one. Under the synthetic workloads and carbon traces, simple overnight batching is highly competitive on average modeled carbon and safer on critical tier misses. Carbon only objectives fail as stress tests and should not be anywhere near production clinical queues. The next step is local validation. Replay these policies in de-identified hospital on like de-identified hospitals arrival times for the jobs, um, actual GPU mix, and marginal grid carbon or tariff data. Hence, the future discussion question or the research question that we propose to work on is like, what local grid race would actually be strong enough to justify paying the operational cost of a complex scheduler. Yeah, with this, we conclude the presentation.
Okay, thank you so much for your wonderful presentation. I have one question related to data. How do you intend to collect data from local or some in global aspect, maybe free or some sensor installation or something else?
From what I understand, this is going to be like, we haven't like actually talked with a hospital yet, but we also understand that we cannot just directly go to a hospital and ask for that data. That would definitely need like some privacy screening because it could be like some censored data or something. So I think our next step is that we get in touch with like clinicians and hospital, like people working at hospital, and maybe like start interviewing with them on like how we can get the data for this, like the real time data, and accordingly like work on it. But if we get a chance to like, collaborate with some big hospitals, like which have like branches all over the world, that would like help us to do some research more better in this area.
Okay, thank you so much. Wish success in your work. Nice presentation. Thank you.
Thank you.
Do we have any other questions?
Have
Since
you
there are no,
feel any limitation over there?
In terms of uh, can you please expand more, like in limitations in terms of like collecting the data?
Collect no, not collecting the data in your system. Carbon emissions you are using. So you feel any limitations over there?
So I think like whatever we currently presented, it was totally based on synthetic simulation. So we don't have the real-time data, but one thing I can say for the real-time data is that it will also take into account how much time it takes to like, upload, let's say, a job data to the cloud in case of hospitals. Because if you have like hospitals, some hospitals in rural environments, then the internet connectivity and everything is not very fast. So even if the job is marked as critical, sometimes like just uploading it to the cloud and getting the results might take more longer time than actually a doctor giving a reply. And since it's critical, it needs to be answered very fast. So I think there are like a lot of open questions out there. And once I think what we start working with the real actual data, we'll see more progress on how things further like go in this research.
Okay, thank you.
Thank you.
thank you for your presentation, ma'am. Now moving on to our next presenter, I would like to call Sir Abhijit Dhaneshwar Jadhav to present his paper on the title Towards Explainable and Multimodal Deep Learning for IVF, a comprehensive survey and a hybrid AI framework for embryo selection. Do we have you here with us, sir?
Yes, I'm here.
Okay, sir.
I hope I'm audible.
Yes,
And
sir.
if you permit, I can share my screen also.
Yes, sir. You may share your screen.
Is my screen okay, visible?
Yes, sir.
Okay, fine. So good morning, everyone. I'm Abhijit Naneshwar Jadhav, and today I will be presenting our review paper titled Towards Explainable and Multimodal Deep Learning for IVF, a comprehensive survey and a hybrid AI framework for embryo selection. So in today's topic, I'm going to discuss some of the literature survey statistics along with what we can improve in the existing systems with the help of the research gap that I have identified in the system. So I will be discussing only proposed framework as such. Implementation is in process. So let's talk about that part. Right. So moving to the next slide, this is the outline of the today's session, right? So I will structure my presentation as first I will introduce IVF and the problem. Then I will discuss the detailed literature survey followed by motivation research gap. Then I will present our proposed MEAIF IVF model with the help of architecture diagram. And then finally, I will conclude with the what are the future research directions. Now, in introduction, infertility is a major global health issue, and IVF is one of the most effective assisted reproductive technologies that we are seeing from last so many years actually. However, the success of IVF strongly depends on selecting the quality embryo, best embryo for implantation. Traditionally, embryo evaluation is done using morphology grading, right? But this method is subjective, varies across experts, and lacks consistency. That is the general issue that the hospitals and various expert doctors in this area are actually facing. To overcome these issues, AI techniques are being introduced to automate and improve embryo selection. So like we know AI can uh, help us to have revolution in every area. So same here also, right? So now coming to the literature survey, let's talk about how much survey is done in this area using different models. Like I have taken, for example, the deep learning based approaches used in IVF. If you will see the first paper, Kosravi et al. and its co-authors used CNNs and achieved around 90% accuracy in embryo grading, right? Then next one is, you can see Tran, and its co-authors incorporated time-lapse data and achieved that a curve of approximately 0.93 for pregnancy predictions based on that embryo plantation. Then Berman and its co-authors improved classification consistency with the help of deep neural networks. Then you can see Miyagi and Vermilia also contributed towards automated embryo quality and viability prediction. But overall, if I'll explain, these models show high accuracy and automation capability, but suffer from few limitations. You can see like limited generalization is there. Small data sets is also a major reason. We know the accuracy of the AI models is improved with the data sets, the quality data sets. That quality in data set is important. And when we are trying to generalize the system geographically everywhere for any individual, then large data sets must be passed to have that accuracy wherever we apply that model. And this is when we talk about healthcare, we cannot take that risk with the small data sets training to the model. So I see that is also as one of the limitation and lack of interpretability. It is there with almost all AI models. But yeah, that is also one of the issue that I have observed. Now, considering the next few papers which are based on the multimodal and clinical systems, like you can see, the first one is Chavez and Badiola integrated clinical data with machine learning for personalized predictions. So what I said in the previous slide, when we want to generalize it, right, then the AI model should have a large data set, but now here they try to personalize, find out what are the personalized predictions. Then Messiger and Basile focused on morphokinetic analysis using time-lapse imaging. This is also one of the important contribution from these authors, because like basically when we talk about AI, the data should be a combination of the various types, like imaging, time lapse imaging data sets are also important, and feature based data sets, text based data sets are also important, because we cannot rely on only few of the attributes for getting a better model. Then Scott introduced genetic screening methods like PGT to improve IVF outcomes. Wang provided a comprehensive review of AI applications in reproductive medicine. He has presented few of his observations in AI applications in reproductive medicine systems. And then we see what we can do is we can improve prediction accuracy, right? And what these accuracies or they often require is expensive equipment, large data sets, as I said, or complex clinical integration is also required nowadays to improve that accuracy. So can we have a solution in mid of this which can uh, bear us up to some extent from buying expensive setup and complex integrations? And also with large data sets, can we have better accuracy without that investment? So let's move on that. Now this from where it has been actually idea clicked. So what is the motivation is, the motivation behind work is we thought of to reduce the subjectivity in manual embryo grading, which is more in basically India, right? This is happening to improve implantation live birth rates. That is also very important, right? So embryo implantation is okay, but what we are facing is the conversion of those embryos into actual reproduction and live birth rates is very less. So that is where I thought that we can, if with the help of AI, if we can work on the quality embryo selections, then that can increase the rate of that live births from the implantation. So that thought has clicked actually to do this work to enable intelligent decision support systems for embryologists, right? It will definitely help them. And to integrate multiple data sources for better prediction accuracy. That is what I explained in the last slide. Like, yeah, not depending on only a type, simple type, single type of data. that will not work. But text based lapsing imaging data is also very important. Text based data is also important. So all types of data we should include in our data sets for training a specific model. Now, coming to the research gap that I have identified based on the literature survey. So, what are the few important points that I observed is most systems rely on a single data types that I already explained. The lack of generalization across different IVF centers. So, we have seen that few papers which are working on small data sets and personalized predictions. So instead of that, can we focus on generalization across different IVF centers? If that can be done, then I think this will be one of the important work that can help in revolution of IVF sector. Then limited explainability of AI models. This is a problem everywhere in all AI models almost, which are giving blind predictions. Small and biased data sets, obviously that is an issue, and lack of multimodal integration of clinical and genetic data, as I said. So now based on this, let's focus on how we can improve with the help of the existing AI, machine learning and deep learning techniques. I hope it is uh, visible to everyone. Now, to address these issues, we propose a multimodal explainable AI framework, right? It is called as a MEAIF IVF model, right? So what is this framework? It basically integrates embryo images, time lapse, morphokinetic data, and clinical patient data. So these are different types of data we are considering for this framework. Then it uses what kind of techniques? So CNN vision transformers for basically special feature extraction, we are using it. Then LSTM networks for temporal modeling are required, and attention based fusion for combining this all features. So these techniques we are using. Additionally, to achieve that explainability, what I said in the last slide of the research gap, so how to achieve that explainability and how to avoid those blind results, we are using gradcam for visualization and chef for feature importance. So we also incorporate federated learning for privacy preserving multi-center training if we want to go with the IVF as a generalization part, right? So this can be done. I hope so. This can be done. Let's hope it is in process. Some of the part I have tried to implement also. The code is generated, the model is somewhat working, but I couldn't get that much accuracy. But still, it is in process. I cannot say it is completely executed. What I have done, I have used some existing data sets like known implantation data, and the second that time lapse imaging data set. These data sets I have used, and I tried executing the model. I have tried using all these steps, but okay, fine. Now some part of the model can be changed in future, and I'll try to get more and more accuracy. So research is going on, and I hope I can have some success in it. So now coming to the let's conclude this topic. Whatever was the important things that I can explain, I have tried to explain my best way. So to conclude, AI has significantly improved embryo selection in IVF. Obviously, we need to accept this fact. Deep learning models provide higher accuracy and consistency. That also I have observed. That's why I included my one of the slide as deep learning models based. So many references I have used, almost more than I can say 220 references I learned. This work I'm doing from last 6 to 8 months. But yes, whatever I have observed is deep learning models providing higher accuracy and consistency. But however, multimodal and explainable systems are needed for clinical trust that are observed. So our proposed model addresses challenges, the challenges like multiple data modalities, explainable AI, and federated learning. These things that we are trying to handle. So now, if we talk about the what is the future scope, so as I said, we need to generalize it. So large scale multi-center validation is required when we come up with the final system. Integration of genomic and metabolomic data is also required, and development of real-time AI assisted IVF systems that has to be deployed. And this is very important and one of the important innovation, because every when we talk about any family, right, the biggest dream of their life is to get a live birth, of the child, and that is what where we can help them who cannot get it naturally. And I thought this is one of the important thing field where we can do the research. So these are the future research aspects if we can develop, and we can uh, actually deploy the real-time AI assisted IVF systems. So up to that extent I will be continuing my work. And then coming to uh, that, I want to give the credit to these authors who have done remarkably very good work, and let's try to extend it. You can see here, right? These are some of the key references that I have explained. Khosravi, Tran, Borman, right? So they have done a good work. Thank you very much for giving me an opportunity to present my work in the conference. I've done with my presentation. Over to you, sir.
Thank you so much for your nice presentation. Topic C is interesting and very useful about the explainability of artificial intelligence. I saw in your model some issues about privacy. How do you intend to keep this privacy?
Privacy is very important, madam. Basically, uh, like whatever data that is coming from the patient side, or whatever is coming, we will try to protect it through some, if we can bring the authentication based systems when we will finally deploy these AI assisted systems, and we can put some deep learning techniques which can help us in preserving privacy. That have to look into the things. Once, madam, I will get the desired accuracy, then we will think on these aspects also. And I know this is very important aspect that I need to consider. But right now what I feel is the quality attribute that I should work on is accuracy. So still that work is going on, and hope so I'll come up with that answer also soon.
Okay, thank you so much. Thank you.
Thank you, madam. Thank you.
Thank you, sir. Do we have any other questions?
Dr. Latika Desai, madam, is there any question, madam? Nice to see you in the presentation event.
No question. Thank you.
Okay, thank you, madam.
Thank you, sir. Now, moving on to the next presenter. I would like to call Ma'am Piruru Gayatri to present a paper on the title TTP Detection and Prediction of Cyber Threat Techniques using Logbird and Graph Neural Network. Do we have you here with us, ma'am?
Yes, sir. Am I audible?
Yes, ma'am.
Yeah, I'll share. Good morning, everyone. This is Gayatri from Amrita Vishwa Vidyapeetham, Coimbatore. Today, I'm presenting my work on detecting and predicting cyber threat techniques using a hybrid framework combining transformer-based log analysis and graph neural networks. Just a second. Yeah. Our objective is not only to detect attacker activity, but also predict what an attacker may do next, enable proactive defense. So the problem and motivation for this is, so basically traditional rule-based systems struggle with figuring out and detecting unknown attacks and context understanding and what is the attack progression prediction. And traditional IDS and SEM systems also mainly focus on identifying attacks of after they occur. However, modern attacks evolve through multiple stages. Security teams need accurate detection, faster response, and predictive intelligence. So the key limitations are like these lack adaptability and generate high or false positive rates, and they do not understand behavioral context or semantic meanings. So the research motivation here is we are designing a framework that combines contextual understanding of logs and attack sequence prediction. So existing approaches are like transformer models are used, but that are good for good contextual understanding, but they are not able to predict future attack steps. And graph models are also able to capture attack relationships, but they lack semantic understanding of lag. So we are proposing a hybrid model of detecting TTP, which integrates deep learning and graph-based models. Use of graph neural networks in description of attack relations and dependencies. A predictive capability of future techniques of cyber threats through a thorough testing of system effectiveness based on conventional performance pressures. So these are the key contributions, as we said. Yeah, we are creating a pipeline where we are automating all the attack techniques and classifications from enterprise security logs, and we are then creating a pipeline where we are adding a predictive capability for forecasting next attacker techniques. This is an end-to-end system demonstrating a practical SIM integration. So the methodology overview is like we are creating a proposed framework where that follows a multi-stage analytical pipeline where we are collecting all the logs from attack simulation of tools called Red Dot, Atomic Red Team, and Caldera. And we are collecting logs. We After we generating realistic attack logs from Atomic Red Team, and we are converting them into XML event logs into structured data sets for machine learning. And we are pre-processing in such a way that it can be trained using logbird. Yeah. See, Atomic Red Team executes attack techniques including like execution, persistence, and privilege escalation. All these process
Your
creation
voice
commands provide structured XML format and event data, system data, Python based. Sir, am I
no, ma'am.
audible?
Yes, ma'am, you're audible.
Yeah. So we are using a Python-based pipeline that was designed and developed for pre-processing structured log data for machine learning purposes. The window event logs were traversed using OS for file traversal and XML.E3.elementary used for parsing, and RG libraries for cleaning for the patterns, and CSV for generating structured output. The system traversed all XML files and used namespace aware XPath queries. So all these pre-processing and missing values were standardized. A textual feature was creating by consolidating relevant attributes into command line arguments, process hierarchy, and file metadata, while noise was removed using regular expression-based normalization. The parsing of attack technique labels was performed using literal.eval function by splitting the delimiter, therefore normalized to consistent format depending on the scenario. So multi-label binarization for used for multi-level scenarios. So we are using logbird for transformer technique for technique detection. So after these pre-processing, the structured event text is passed into BERT. BERT first performs tokenization where text is divided into smaller units called tokens and converted into numerical representations. These tokens are then transformed into embeddings which capture semantic meaning. Self-attention and allows the model to analyze the relationships between different parts of the event simultaneously. Rather than examining individual words, the model understands the context instead of words. So the model can learn a command, parameters, and its parent process together that can indicate a specific technique. After passing through multiple transformer layers, the final representation is sent into dense classification layer. The model was implemented using Hugging Face transformer with PyTorch. During training, the maximum token length was selected based on observed command line distributions. The Adam W optimizer was used for stable learning, and early stopping was applied to reduce overfitting and improve generalization. And after detection, we are using graph neural network for next technique prediction. Uh, so this sequential behavior which we are trying to predict, is only is able to predict based on the detected TTP what can be the next based on the previous data collected from previous attacks. Um, unlike traditional sequence models, a GNN learns not only from direct transitions but also from neighboring relationships in the graph. Each node develops an embedding which is learned a numerical representation that captures its contextual behavior within attack paths. These embeddings contain information about which techniques commonly appear before and after a given technique. In simple terms, the model receives the currently detected attack technique and estimates the most probable next actor action. The model uses graph convolution layers to aggregate information from neighboring nodes. Nonlinear activation functions are applied to capture complex attack relationships, and dropout declaration is used during training to reduce overfitting and improve generalization. So after detecting output and just predicting the output, we have created a pipeline using Splunk, using HTTP event collector to integrate into Splunk as an application and dashboard. These are the experimental results we got from Logbird. So this is the proposed Logbird where we got accuracy of 75% and F1 score of 0.9262, where the generic models like log analysis DistillBird, which is lightweight, it got only 40% accuracy and F1 score of 0.22. And DistillBirds and CyberSecurityBird and SecurityBird, these only got of 90% accuracy and 0.8545 F1 score. And coming to prediction performance using graph neural network, we are using top 5 accuracy where it goes on increasing the accuracy, where we got top 5 accuracy as 78.26%, which will give us more accuracy. If we have more data on based on previous data sets, we may get more accuracy. Because of the lack of the data, we are getting this. The top 5 prediction accuracy of 78.26 means system successfully shows the narrowest possible actions to 5 likely techniques, enabling proactive defense preparation and resource allocation by security analysis. So coming to real world Splunk integration results. Let's say we are detecting a benign activity, and what can be the next predictor? It shows none, and there is we are able to detect T1003, that means credential sharing technique, and then we are able to predict what can be the next, like T1059, which can be a command line argument is being run by the attacker. Like this. Following the detection of T1003 credential dumping, the graph neural network predicted the next likely technique like as T1059, like command execution or PowerShell usage. This prediction aligns with typical attack progression patterns and provides analysts with actionable intelligence and preemptive defense. So this combines it. So this can be used in a practical enterprise integration, like it is like SIEM compatible, seamlessly integrates with the Splunk or any SIEM tool that can be incorporated. This also reduce the latency instead of taking time. The security analyst needs to go through and flag it. Instead of that, we can create an alerts based on timely. So there it can. Sir, am I audible?
Yes, ma'am, you're audible.
Yeah. I don't know where did I lost my connection. Yeah. So based on these, we can future directions are like optimize computational complexity for large scale, explainable AI. Why that particular technique is being used instead of other techniques, even though there are multiple attack patterns we have, and we can integrate real-time real-time data threat intelligence feeds for enhanced model generalization, and we can we can
Sorry to interrupt, ma'am, but your voice is not.
optimize the regular model updates to address emerging attacks methods. Represents a promising am I audible now, sir?
Yes, ma'am, but it's breaking in between. It's okay, you may continue.
Yeah, sure. So by combining logbird transformers for detection and with graph neural networks for prediction and integrated results into Splunk for operational deployment, the framework achieves 95% detection accuracy and 78.26% top 5 prediction accuracy. This hybrid methodology demonstrates the significant potential of artificial intelligence to enhance threat detection capabilities and accelerate security response and strengthen organizational defense against sophisticated cyber adversaries. That concludes my presentation.
Oh, nice presentation. Can you elaborate little bit related with the time complexity?
Ma'am, since
Ma'am, your voice is not audible properly.
control environment, there will be real time. Just am I audible now, sir?
Yes, ma'am.
So, ma'am, since we are doing in a controlled environment, the latency will be very low. But if we are trying it in enterprise environment, there will be millions of logs per second getting into Splunk server. So there will be more latency. So we should do some research on how to reduce that latency.
Yes, thank you.
Yeah.
Do you have any other questions? Since there are no more questions, we'll be moving forward with the next presenter. Thank you for your presentation, ma'am.
Thank you, sir.
Now I would like to call again Ma'am Siti Dwi Hastuti to present a paper on the title Democratizing Digital Archive Learning for SDG 4 Inclusive Education Using a Cost-Effective VBA Excel Framework. Do we have you here with us, ma'am?
Good morning, everyone. Today I am proud to present our research titled Democratizing Digital Archive Learning for SDG 4 Inclusive Education Using a Cost-Effective VBA Excel Framework. This study addresses a critical infrastructural barrier in higher education and proposes a highly scalable solution for research-constrained environments. To set the context, the modern workplace of the term Archive 4.0 requires graduates to be highly proficient in digital course management. However, we identify a safer theory to practice gap. Students understand the theory, but because professional content management systems are expensive, they lack hands-on practice. This financial barrier systematically marginalizes students in developing regions and directly threatens the inclusive education mandate of SDG 4. To address this inequality, we develop a disruptive, zero-cost pedagogical innovation. We transform standard Microsoft Excel into a fully interactive virtual laboratory using a VBA or Virtual Basic for Application. Our design is deeply rooted in the cognitive fluid theory. By completely masking the complex spreadsheet grid behind a clean user interface, we eliminate extraneous cognitive load, allowing students to focus entirely on learning or archiving skills without the financial burden of commercial software. There is a research methodology. Our methodology utilizes the structure AD model for research and development. We implemented this framework with a cohort of 40 undergraduate students who had completed theoretical modules but lacked practical exposure. Importantly, we test this in a laboratory equipped with basic, low specification computer to ensure real-world resilience. We, col- we collected data through expert validation, pre and post tests for learning outcomes, and standardized usability surveys. There are a framework, development, and UI design. As you can see from the figure on the screen, we transition from basic wireframes to a fully functional interface. This UI perfectly simulates a professional environment. It includes secure authentication, dynamic metadata entry to prevent typing errors, and a real-time search engine. Most importantly, it utilizes data masking to completely hide the raw Excel code, forcing students to interact strictly with standard archiving protocols and preventing accidental data corruption. And next is system architecture. This diagram illustrates our lightweight, the three-tier system architecture. User interact exclusively with the presentation layer via the PBA user forms. All actions, such as creating or searching reports, are processed by the business logic layer through embedded PBA macros. Finally, the data is secure routed to the data access layer, which consists of hidden, password-protected worksheets. This ensures high data integrity while maintaining zero licensing costs. And there's an expert validation result. Before bringing this to the classroom, the framework underwent rigorous validation by both archophile academics and IT professionals. The results were outstanding. The framework scored a composite average of 4.35 out of 5.0, classifying it as highly valid across content accuracy, software stability, and pedagogical UI design. The expert conclusively declared it ready for immediate classroom deployment. To measure pedagogical efficacy, we evaluate the student over a 4-week intervention. The results were highly significant. The mean score jumped from 60.550 in the pre-test to 84.20 in the post-test. Furthermore, we achieved a normalized gain score of 0.61. In educational research, this firmly sits in the moderate to high effectiveness category, proving that our simulation successfully bridged the cognitive gap between abstract theory and digital practice. Beyond the scores, user experience and accessibility are vital. The framework achieved a system usability scale score of a 76.5, which is considered good to excellence. Its meaning, highly intuitive for novices. More importantly, aligning with the SDG point 4, 92.5% of students felt eliminated financial barriers to learning. Furthermore, 95% respondents confirmed that the software ran perfectly on their own, often older, low specification laptop, proving it truly bypasses hardware limitation. And then we must acknowledge the framework's limitation. It is strictly an educational simulation. While it features password protection and hidden sheets to teach security principle, it inherently lacks the cryptographic security of true enterprise SQL database. And additionally, our study utilized a single cohort. Future research should employ control groups to isolate the impact further and aim to scale the VBA architecture to include advanced archive 4.0 features like digital signatures and automated disposal alerts. And in conclusion, our research proves that strategic low-cost technological intervention that effectively democratize education. This zero-license PBA framework successfully bridged the theory-practice gap by reducing cognitive load and providing an authentic simulation environment. Because it operates entirely offline on a low specification hardware, it serves as a highly scalable and pragmatic solution for marginalized educational ecosystem, directly fulfilling the inclusive education mandates of Sustainable Development Goals Point 4. That concludes my presentation. Thank you for your attention and thank you for your time.
Thank you so much for your presentation. Important topic. What are your future plans? Can you hear me?
Yes, ma'am, your voice is audible.
Okay.
Yes, ma'am. For the future plan, maybe should focus on scaling the VBA sector to integrate advanced archive 4.0 features, such as a digital signature verification, immutable audit trail logs, or automated disposal alerts. And methodologically, we also plan to employ quasi-experimental design with control groups to further isolate the framework's impact.
Okay, nice plans. Thank you.
Can you please elaborate a little bit related with the security, how it is more effective than the cryptographic security?
I think there's some network issue at our end, so let's just continue with the session.
Okay.
So this brings us to the end of the session. I sincerely thank all our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this virtual conference. We'll be happy to have you in the next version in 2027. All the presenters will be getting their digital certificates through email within 2 working days, and the publication will be live within 7 to 8 weeks. So I request you all to kindly cooperate with the team of TIBS 2026. I also thank both our session chairs, Professor Malika Ainova and Dr. Latika Desai, for chairing this session. I would like to present a token of appreciation to both the chairs on behalf of Team TIBS 2026 and Global Knowledge Resource Foundation and partners. And I also request both the chairs to share their remarks with the participants. Ma'am Malinga, Ma'am Latika, would you like to share your remarks with the participants?
Thank you so much. Thank you for your invitation and for this opportunity to be a part of this wonderful conference.
Thank you, ma'am. Ma'am Latika.
Good morning, good afternoon, and good evening to all. And all authors have presented the paper nicely. As a good researcher, we have to see the same work. Those are in at the current scenario, and we have to compare it, and we have to try to enhance it. This is submission from my side. Thank you, Malinka madam. Nice to see you here. Thank you, Ashutosh. Thank you, GR Foundation, for giving this opportunity. Thank you.
Thank you to Dr. Latika Desai that I have this opportunity to meet you online and to have pleasure to lead this session together with you. Thank you so much. Thank you.
Thank you.
Thank you, ma'am. Thank you, everyone, for joining. Just before we end the session, I request you all to kindly switch on your camera for a quick snapshot of the virtual conference. Thank you, everyone, for joining. Have a good